Okay, here are the notes for 4.4, 4.5. I will be able to list and apply transformations to the graphs of the 6 trig functions. Okay, so these transformations are a lot like other transformations that we've looked at, but there's some other vocabulary words that we use when we're talking about trig functions. So the first one is amplitude, and that's the half the distance from minimum to maximum. So just to give you a little sketch here, if we have a function, a trig function like this, the amplitude would be from here to here. This is our amplitude. Okay, or from here to here is our amplitude. Period is the time it takes to repeat. So with all of our functions, they repeat at some point. So for instance, the sine wave repeats. This would be the period. So from here to here is our period. Okay, a phase shift moves the function left or right. So just like a horizontal transformation, and the vertical shift moves it up or down. So here we have our function. And so it's just like how it was before. The outside affects it vertically, the inside affects it horizontally. So on the outside here, my A is going to tell me my amplitude or my stretch. And we'll get more in detail in a little bit. This is B here is going to be a horizontal stretch or shrink. Which is also known as the period, because if we stretch or shrink it, we're changing the period or the time it takes for the function to repeat. And so we'll again look into that in a little deeper in just a moment. And our C is going to give us our horizontal shift. With trig functions, we call that a phase shift. And the D, or adding or subtracting on the outside of the function, is going to give us our vertical shift. And as before, these pluses and minuses here are going to do out front, so right here, these are both going to be reflections. Vertical reflection out front and a horizontal reflection inside. And remember, horizontal means we're going to go over the y-axis, verticals means we're going to go over the x-axis. All right, so let's first talk about the amplitude or the vertical stretch, so the height of the wave. So the big thing that we're going to do a little bit differently with these graphs is instead of getting a graph that's already numbered and then making our graphs fit to the numbers, we're actually going to make our numbers fit to the graph, and it's going to be a lot easier for us that way. So I'm going to go ahead and draw in an x and y axes. Now I'm going to number this per my amplitude. So if my amplitude right out front there is 2, then rather than calling this 1, or I could go up to here and call this 2. It doesn't matter where you put it, just as long as you call it 2. Okay, and then on our x-axis, for now we don't have any period changes, so we're going to go to 2 pi. Half of that is pi, half of that is pi over 2, and then we can just count up for 1 pi over 2. This is 2 pi over 2, 3 pi over 2. 2 pi over 2 just simplifies to that. So once you get down to here, you can just count up. And that's going to be a big part of this, is counting by the fractions you create. We'll see that in a little bit, a little more. All right, and then we have the sine function. So we know the sine function starts here and follows this pattern. And you just draw it in. Make sure that they are curved and not pointy. Oops, I made a mistake there. Okay, there we go. All right, so now we have 1/2 cosine x. So draw on your x and y axes, and then go ahead and just mark off your y axes with a mark and call it 1/2 and negative. This should be negative down here, so negative 1/2. There you go. And I actually went 2 blocks down and 2 blocks up just to show you it doesn't matter where you put it exactly, just as long as you number it correctly. So our amplitude for this is 1/2. And then the x-axis is going to be the same as it was over here. See, the only thing that changed on here for the cosine function is that we just labeled it differently right here. All right, let's look at the tangent. So we talked about amplitude being the height of the wave. So what happens when you have something out here? Does it affect the amplitude? Well, it doesn't affect the amplitude, but it's still a stretch. So we have, in this case, a stretch of 2. Okay, so I'm going to draw my x and y axes, and I'm going to center it this time. The reason I center it is because remember that the period for the tangent function is pi, but the 0 right here goes right through 0, and it kind of looks like this. Okay, so I'm going to center it, and then I'm going to put half of pi, so pi over 2, on either side. And I'm actually going to skip a block here because one of the anchor points that we need occurs at pi over 4. So let's go to pi over 2, negative pi over 2, and this is positive pi over 2. And here's where we have our asymptotes. Draw those in. And now the stretch is important here, so we do want to mark this. Now before, our parent function at pi over 4, if you look back when we graph these, is at 1, right? So if pi over 4 is at 1, and then 0 is 0, and then negative pi over 4 is negative 1. I always forget my negatives here. The stretch is going to affect this anchor point. So we're actually going to move this up to 2, or you can keep it there, but then you have to label this as 2, and I do want to see a dot there. It goes up like that, and we have a dot here, and this is going to go like that and approach our asymptote. Should probably curve a little bit more like this. No, I'm not looking for wonderful artistry from you on these graphs. I'm looking to see that you know where the points go. I messed it up when I was fixing it. There we go. Stretch up to 2. Like that. Okay, so if it's not perfectly curved or doesn't look like it's the exact shape, I'm okay with that as long as I can see that you have the right measurements and points in there. A period is a horizontal shrink or stretch. So how do we know when we're looking at a period or that we need to change the period? Multiplied on the inside, and remember that on the inside it's opposite. So inside opposite, a fraction between 0 and 1 is a stretch, and a number over 1 is a shrink. So let's quickly look at what we have going on here. Here with this 2, we have a shrink by 1/2. Shrink of 1/2. Here over here, 1/4 is actually a stretch by a factor of 4. So let's see how we're going to figure this out then. And there's actually a little formula that we can use. Since a period is 2 pi, so for all functions except for tan, 1 period is 2 pi. So let's just try this out, and then I will write the formula for you down here. So 1 period is 2 pi. That means I'm going to take for this one 2 pi and multiply it times 1/2. If I multiply it by 1/2, I get pi. So for this one, my period is pi. All right, period, pi. Okay, let's go ahead and find out the period for this one. So I would take 2 pi, and this time I'd multiply it by 4. Excuse me, I was going to do 1/4, but we want to multiply by 4. And so my period is going to be 8 pi. Okay, so let's go ahead and graph those. Okay, so we don't have any change in amplitude because we're just handling these one by one right here. So I'm just going to make my amplitude +1 and -1. Okay, now here's how you change the period. You're still going to go 4 spots. So 1, 2, 3, 4. And you're going to mark your period as pi right there. And then you're going to divide it in half. So you divide it in half to right there. This is pi over 2. Okay, you're going to divide it in half again. This is pi over 4. Okay, so each of these is pi over 4. So I have pi over 4. I have 2 pi over 4, which simplifies to that. that makes this 3 pi over 4. So that's how you're going to do this. You're going to divide in half, and then count up by the unit that you have. Okay, so the sine function, up and then down. So the look of the function didn't change, but our period did change, and we're showing that just by numbering it differently. There you go. So make sure that your axes are numbered in a way that I can read them. Okay, so now we're going to stretch. So again, this isn't affected on this one. So 1 to negative 1. We're going to go over 4. 1, 2, 3, 4. And we set our period as 8 pi. Make this 8 pi. Divide it by 2, and I get 4 pi. Divide it by 2 again, I get 2 pi. And this one's pretty easy because 2, 4, 6, and then 8 pi. Okay, and this one's the cosine. Go there, to there, to there, to there. There we go. All right, now let's look at tangent because it's a little bit different. Since our original period on a tangent function is not 2 pi, it is pi. So we're going to have to start with pi, multiply by 1/2, and we get pi over 2. Okay, so now let's change that and graph that on our graph here. Okay, so pi over 2, that means from this side to that side, we have to go pi over 2. And I'm going to go four spots in between. So we're starting here, and we're going 1, 2, 3, 4, because I want to show those anchor points. And then I need to go half of this, right? Because this is just, pi over 2 is the whole thing. So from here to here is going to be, well, pi over 2 divided by 2 is pi over 4. So you can see how you really have to get your fraction strength going for these. Okay, so pi over 4, that makes, if I cut this in half, that makes this pi over 8, and that's going to be useful for my anchor. And these are negative, negative, pi over 8, positive. And this is where we have those asymptotes. So we're going to draw those in. And then our amplitude, or for this stretch, since it's tangent, has not changed. So we'll just go 1 and negative 1. I have a point here. I have a point at halfway between these. And then we're going to go up. That. And I'm going to draw right through my numbers here like that. Okay, so I want to see these anchor points as well. All right, so let's pull it all together then. So we do have a couple of formulas that we can use. You can think of it that you are multiplying by the reciprocal of this, or what I think is a little bit easier is to just keep in mind these formulas. Because if you look at our function on the front of our notes, and let's take a peek at that really quick. B, that's the horizontal stretch and shrink. It's not the period, but you can use it to create the period. So now let's go back over here. And our formula, we're going to take 2 pi and divide it by b each time. So if you can find the b value in your function, you're going to divide that into 2 pi. Formula 2 pi over b for all but tan and cotan. And then for tan and cotan, we're going to just take the pi and divide it by b. You can just use this formula to come up with your period each time. Okay, so now let's look at phase shift and horizontal translations. So before we were just working on how to renumber our X and Y axes, now we're actually going to start moving those graphs around. And when we put this all together, I'm going to show you a strategy on the last page here, how you're going to number them first, get in a modified parent, and then start moving it around from there. So we're going to do left for positive C and right for negative C. So we're talking about inside here. So again, it's opposite than what you would think. Negative, even though on the x-axis the negatives are all left, it's going to move our function right. As I said before, I'm going to put in a parent function, and then I'm going to move it because that's going to help me out here. So I'm at 1 and negative 1, and the period's not changing because we're just doing this one thing at a time here. So let me put in all my little marks here. So I have pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to draw in my parent function of sine with a dashed line here. So we can actually see it change. And now, where am I going here? So I'm going to go right pi over 2. It's nice and easy when the squares that we have here are the same increments of how much we want to move. So pi over 2 is just one square. That makes things really easy. I can just go here and move everything to the right. And you always need a little bit over on this side because when you move things, you're going to need this part over here as well. Okay, so draw that in there as nicely as you can. Whoops. Just like that. Now here's for a challenging one. So let's start off by numbering this as we normally do. So we have 1 and we have -1. Okay, and I'm going to draw in a dashed cosine function here. So it starts up at 1, comes down like that. Something like that. Okay, so I need to go, well, positive means left. I need to go left pi over 3. Okay, well, not only is this not a pi over 3 right here, but I wouldn't even know where pi over 3 is as compared to pi over 2 unless I found a common denominator. Right, so what's a common denominator between 3 and 2? Well, 6 is a common denominator. So I'm going to change all of these so that I have a 6 on the bottom. So pi over 2 would be 3 pi over 6. And then we have 6 pi over 6. And we have 9 pi over 6. And last we have 12 pi over 6. And then I'm trying to go left pi over 3. Well, I need a common denominator here too. So this would be also left 2 pi over 6. Okay, so now I have increments that I can work with. I know it's 2 pi over 6, and all of these are over 6. So I just need to figure out, okay, well, if this is 3 pi over 6 from here to here, if I divide this up into 3 parts, 1, 2, 3 pi over 6, then 2 pi over 6 would just be 2 of them. So I'm just going to go down here and divide all of these up into 3 parts. And now I'm going to move all my points to the left. Better make some over here. 2 spots. Okay, so I have a point right here. So that means that this point needs to go over to there. This point needs to go over to here. This point needs to go there. This point down here needs to go here. It's nice if you have 2 different colors to work with. This one's going to go here. And then this one's going to go here. And then you just need to draw it in. How am I going to know you figured this out? Because you're showing all this work. You're showing that you divided this up and you came up with a common denominator. All this stuff will show me that you are at an advanced level and you know how to move this by the specific increment that you were given. All right, now let's look at vertical translations. Luckily, these are easier. Simply move up or down. So pause the video, draw in your parent cosine function, and then give it a try. See if you can just move it down 3. Okay, I got a little lazy on this one. I didn't mark up my x-axes just because I know nothing's occurring, any changes on there for this one. So we're going to move it down 3. So what that means is all these points on here, all these anchor points need to go down 3. So 1, 2, 3. 1, 2, 3. And something that I also like to do is draw in my new x-axis as a dashed line or just a little bit lighter so that way I can kind of follow that line again as I redraw it. So this whole axis would go 1, 2, 3 down right here. Draw it in a light yellow. Not very straight, but there it is. 1, 2, 3. 1, 2, 3. 1, 2, 3 kind of helps us see. Whoops, I grabbed the wrong one here. Kind of helps us see that these points that were on the axes above should also be on the axes below. And then that'll help us see that that one was wrong when I put it there. So I can start seeing my wave develop. And there we go. That is a vertical translation. This should curve back down. Look at reflections. Nothing's tricky about these either. We're simply going to reflect them, but some weird things happen because of the symmetry of our graphs. Okay, so remember on the outside we have a vertical reflection, which means it's going to be over the x-axis. And over here, since it's on the inside, it's going to be horizontal reflection over the y-axis. Okay, so go ahead and pause the video and see if you can draw in your parent function and then also the reflection. Okay, so here's my parent function for the cosine, and now I'm going to reflect over the x-axis. So this up here is going to go here. Anything that's actually on the x-axis is going to stay right where it is. So this is going to stay here, this one's going to move up here, this stays here, and this one's going to move here. Stays, moves. And we're just going to, whoops, totally missed that dot. And we're just going to draw them in. Just like that. All right, now let's go ahead and give this one a try. Here's my parent function again. And then when I go to reflect this, well, on the y-axis, this one's not going to move. This one over here is going to end up over here. The one that was here is going to end up over here. This is going to end up there. So you can see because this one has even symmetry, when you reflect it over the y-axis, you end up with the exact same function. That would be different with the sine function because the sine function has odd symmetry, if you can kind of picture it in here. When you reflect it, it is going to look different. All right, so now let's pull all this together. And I've taken the time to write out notes of every step here. So, and also put our function and what it looks like right there. So list the amplitude, stretch, period, phase shift, vertical shift, and any reflection. So we're going to go ahead. First step is to actually list all of these things. So I do have an amplitude here because this is sine and not tangent. My amplitude is 4. This negative out front doesn't affect the amplitude. Next, I'm going to take a look at the period. Well, I'm looking for something being multiplied on that x there. And since there's nothing being multiplied on it, the period, well, there's no change in the period, but we want to actually write down that the period is 2 pi. Okay, then I'm going to see if there's a phase shift. So I'm looking to see if something's being added or subtracted inside, so in some parentheses here, kind of like what's going on over here. But there isn't, so for this one I'm going to write none. Then I'm looking for a vertical shift. I'm going to write shift so we don't get it confused with reflection. Stretch, sorry. I'm actually going to write a vertical shift, so this is going to be up 2. And then the negative, well, what does the negative out front do? Well, this is going to be a vertical reflection. Okay, so I've laid out everything that needs to happen here. And now I'm actually going to do each of these things. So let's look back up at our steps here. The first thing we're going to handle here is we're going to make the modified parent. Okay, and the modified parent you're going to draw in as a dashed line. And I want you to do this every single time for me. And this has to do with the amplitude. So you're going to look at the A here. And also your period, which is the B. And you're going to use the one of the two formulas that I gave you on the previous page. So either 2 pi, we'll just write them here, divided by B, or pi divided by B. This one being for tangent or cotangent. Okay, once you've done all that, and I give you directions on how to do that, but I'm just going to show you as I do this. You're going to draw it in. That's going to be one step. And then you're going to handle all these other steps below by moving the points. Okay, so all of this is going to occur afterwards. And this is when you'll draw the solid line. Let's call it a line, even though it's a curve. This one's going to be up here, dashed. Okay. All right, so let's give this a try. I know this video is getting long. Thank you for hanging in there. It's a lot of information with a lot of detail. All right, so amplitude 4. So we're going to start off and write the amplitude. Doesn't matter where it is, just matters that you label it, -4. The period is 2 pi. So this one's pretty easy to number here. 2 pi, pi, pi over 2. Then we go 1 pi over 2, 2 pi over 2, 3 pi over 2. And we're going to draw in our modified parent. So it's the sign, and we're going to draw this in dashed. Okay, so we've gone through and draw the modified parent. Now I'm going to handle all these other pieces, and you can do them step by step, or you can just do it as one thing and just move each of these points. So the phase shift, it doesn't need to move left or right at all. It does need to move up to and a vertical reflection, but I'm going to do my reflection and then I'm going to move it. Okay, so reflect, well, this point's going to stay right there, but then I need to move it up 2. So 1, 2. Since I'm moving something up or down, I'm going to go ahead and draw in another axis here because that's going to help me out. Make sure I'm keeping track of everything. Okay, so this one I'm going to reflect. So it was over here, now it needs to go down here and then up 2. This one doesn't reflect anywhere because it's on the axes and up 2. This one, whoops, down here, reflects and then up 2. And then lastly, this one doesn't go anywhere, but as far as reflection, but then does go up 2. There's the positive side. Now I'm going to go reflect here, up 2. Just want to make sure I was on the right track. Doesn't reflect, up 2. There we go. This is our transformed function right here, but I do want to see all this other stuff in there as well. Last problem in this video. Now we have something on the x here and also a phase shift. What that means is we need to factor this out. We're going to practice this plenty in class. So we need a factor. So I need a factor out of 2. Well, nothing changes in the front here. I factor out my 2, x. What we're doing when we factor out is we're dividing. So we're now taking x, or 2x, divided by 2, and we get 1x is how we're getting this. Our sign stays the same, and now we have pi over 2 divided by 2. All right, so we're going to figure this out. Now, we don't really need the pi in there, so I'm just going to do 1/2 divided by 2. Well, that's the same as copy dot flip, so 1/2 copy dot flip. If this was 2 over 1, it's now 1 over 2, which would be 1/4. Okay, so this now becomes pi over 4. Close the parentheses, and my vertical shift stays the same. If you want to double check to make sure you did this right, 2 times x would be 2x. That makes sense. And then 2 times pi over 4 would be pi over 2. All right, so let's go ahead and draw in our modified parent. What I need in here, I do have a amplitude that is changed. My amplitude is 2. Ooh, let's actually list everything first. Amplitude is 2. My period is, well, I take 2 pi, divide it by b, so divide by 2. So this is going to be pi. My period is pi. Then I have a phase shift here, and I am going left pi over 4. And lastly, I have a vertical shift, and I'm going up 1. All right, so we've listed everything. So let's go ahead and draw in our amplitude. I'm going to put it where we would expect it, I guess, for this one. So there we go, 2 and -2. And now my period. So I'm going to go 4 over, and I do have directions above. Hopefully they make sense the way I wrote them. I'm going to go 4 over. I'm going to mark that as pi. I'm going to cut it in half. That would make this pi over 2. I'm going to cut that in half again. That would make this pi over 4. Now I'm going 1 pi fourths, 2 pi fourths. That would make this 3 pi fourths. All right, I have everything I need. to draw in my modified parent as a dashed line. So we're doing sine here. I'm going to put my dots where I need them to be. And I'm going to just draw it in. Modified parent. I'm halfway there. So the other half is kind of tricky here. All right. So now I want to do my moving around. I don't have any reflections, but I do see that I need to move left and up. And I need to move left by pi over 4. Well, lucky for us, actually, I said this one was hard. I was thinking of a problem we're going to do in class. Lucky for us, pi over 4 is just one increment here. So pi over 4, from here to here is pi over 4. That makes things a whole lot easier. I don't have to find a common denominator because all I'm going to do is move all my dots to the left by one box. And I'm going to go up. Well, how far is 1 up? Well, if this is 2, then from here to here must be 1. All I need to do is take all my points and move them left 1 box and up 1 box. So this is going to go off the graph. I'm not going to worry about it. This one goes right here. My x-axis, I'm going to draw it in just because I like to see, helps me see that my function's going in the right spot. So over, up, up. There we go. And draw it in. You will see some harder ones in class where you have to find a common denominator. But for now, you get the main idea here. All right, thanks for sticking with me and watching the whole thing. I will see you in class.